Hello and welcome to this video on a proof of the compound angle formulas for sine, cosine, and tangent. We're going to be starting off using this diagram to prove cosine, and we're looking at the cosine, that angle theta, plus the angle phi. Alright, some call it phi, I'm just going to refer to it as phi. So we have these points right here, A, B, C, D, E, F, G. Wow, creative. But we're going to use them all nicely. First thing we're going to want to look at is we're going to want to look at this line right here, GD. And let's give it a name, and let's just call it N. Alright, we're going to call GD N. So, what we can do here is to find the length of AD, we could use the sine law to do this. And how are we going to accomplish this? Well, looking at the yellow triangle I have here, down in the bottom right, this angle right here, around A, that angle is phi plus theta. So the angle up here has to be 90 minus phi plus theta. All in brackets there. Because when we add this up with the 90 degrees down here, it all adds up to 180. So now, when we write down our sine law, we're going to write down that N over sine phi equals AD, and let's call this side L, equals L over the sine of 90 minus phi plus theta. Now, the sine of phi plus theta, what is that really saying? Well, that's really saying the cosine, if you remember from the video we did last time, where 90 minus the angle is just flipping the opposite and adjacent. So really, what we're trying to say here is that N over sine phi equals L over cosine of theta plus phi. So what about that theta plus phi there? How do we get rid of this? Well, we use another thing. The fact that if you look at triangle ABD, it's similar to triangle ACF. So if we took L, the measurement L, and compared it to AB and the length of AB, because we've written here, very faintly, we write here that this is 1 and these two sides are equal. So because AG equals 1, I'm going to write that, AG equals 1. Because AG equals 1, AB equals the cosine of theta plus phi. So we've just compared L to the cosine of theta plus phi. Right here, AB is theta plus phi, AD is L. And now this is similar to AF, which we said was 1. So 1 over, and then AC. Well, AC is the cosine of theta because it's the x-coordinate on the orange triangle. 1 over cosine of theta. So over here, we can now officially change this into N over sine phi equals 1 over cos theta and obtain that N equals sine phi over cos theta. Alright, we're on track to finding out what cosine of phi plus theta equals. Well, cosine of phi plus theta plus phi, I'm going to write it down though, equals out to L times cos theta, because it's in the triangle ABD, where L's the hypotenuse, so cos theta equals adjacent AB, which is, we already discussed, AB is cos theta plus phi, over L. So cos theta plus phi, I flipped that ratio. Whoops. Cos theta plus phi divided by L. So multiply each side by L, cancel out, and you're left here. L cos theta. So cos theta plus phi equals L cos theta. Now L, what can we do about L? Well, let's invent yet another variable. Let's call length AE R. So from A to E, we have R. All right. So R cos phi equals L. Using that hypotenuse times the cosine gives us the adjacent rule that we just used. Now we can replace L with R cos I cos theta. Okay, we're on our way. We just have to introduce one more variable. Let's introduce the variable S for EG. So we could see that R plus S equals 1 because AG equals 1. So R is going to equal 1 minus whatever S is. So let's figure out a way to get S. Now, this angle right here that I just highlighted is 90 minus theta because it's the other angle in the right triangle with theta. And that means that this angle opposite to it is also 90 minus theta. And this angle right here, just like before, has to add up to 90 degrees with theta. Well, what angle plus 90 minus theta gives us 90? Theta does. So this angle in here is theta. Okay. Now let's look at another angle. This angle right here is 90 minus phi. Getting small here. So what's this angle? Well, it has to add up to 180. So 180 minus 90 minus phi equals, the minus distributes, 180 minus 90 is 90, and then minus phi is plus phi. So this angle is 90 plus phi. Really small, but it's there. So now what we could do is we could use the sine law again to compare 90 plus phi to n and theta to s. So let's go ahead and do that. So now we have that s over sine of theta, is s partnered up with theta, equals out to n over the sine of 90 plus phi. So 90 plus phi, what are we going to do about that? Well, the sine of 90 plus phi equals sine of 90 minus phi. And that, as we discussed before, is going to be cosine of whatever this is. So cosine of a minus phi. So if we have the cosine of minus phi, let's look at how we can express this as the positive cosine. We draw out our unit circle. I'm going to draw one out, just an x-axis for now. Very crude x-axis. When we draw out our unit circle, when we create a principal arm on that unit circle, going up here, ooh, that's a horrible, let's use the line tool. We create a line going up here like this, and we create another one going at minus that angle. So we have one going at phi, and then we have another one going minus phi. What you notice is when you draw a line that goes right between these two, their x-coordinates are the exact same. So the cosine of minus phi equals the cosine of a positive phi. The cosine of a negative angle is the same as the cosine of that positive angle because their x-coordinates are always the same. They're just rotating in two different directions as the y-coordinate changes. All right, so now that that's established, we could reestablish sine of 90 plus phi as the cosine of phi, and then we could substitute in our value of n that we obtained. So s over sine theta equals, what was n? N was sine of phi divided by cosine of theta. And then this is going to be multiplied by 1 over cosine of theta. So cosine of phi, my bad. From here. Now we have this expression, and we could write down that S equals sine of phi times sine of theta, all divvied out by cosine of theta, cosine of phi. All right, we're almost at the end here. Now we just have to multiply r by cos phi cos theta. So r, so cosine theta plus phi, as we discussed, equals r, which is 1 minus s. So 1 minus s, which is sine phi. Let's write it down as theta first, though. Sine theta, sine phi, over cos theta, cos phi, times cos theta, cos phi. All we have to do now is multiply this in, and we have our double angle formula. So this term multiplied into the 1 is just going to equal cosine of theta, cosine of phi, and then when we multiply it in to this term, it's going to cancel out with the cos theta, cos phi on the bottom. So it's just going to be minus sine theta, sine phi. And this right here is our compound angle formula when we add cosine of theta to cosine of phi. So how will we go about obtaining the sine version of this? Well, couldn't be any easier. We could just simply do cosine of 90 minus theta plus phi. So this is going to equal sine of theta plus phi. What we could do is we could group together 90 plus theta into a package. 90 minus theta is 1. And then the minus theta right here, minus phi, my bad, will be separated. So when we equal this out over here, as our compound, we're going to have cosine of, and then we had 90 minus theta as one group, times the cosine of negative phi, we said. It's our other group. Let's go ahead and do this over now. The sine side of things. Sine 90 minus theta times sine of minus, I want to get my yellow out here, sine of minus phi. So how are we going to deal with those? So the first terms over here, we could already deal with this left side, is that the cosine of 90 minus theta is simply sine of theta. Cosine of minus phi, well, we already discussed, that's just positive phi. Okay, now when we subtract 90 sine of 90 minus theta, well, that's the cosine of theta. Sine of minus phi, unlike when we had before in our diagram to prove the negative, where is it? The negative cosine, the height up here is positive and the height down here is negative. So sine of minus theta equals minus sine theta. Anyone familiar with even and odd functions would know that cosine is an even function and sine is an odd function. So this expression right here is going to simplify into minus sine phi. And of course, the minus sign here and the minus here multiply out to make it positive. And then we get our expression that sine of theta plus phi equals sine of theta cosine of phi plus cosine of theta times the sine of phi. And now, all we have to do left is the tangent. So the tangent of our angle, as you discussed, tangent of theta plus phi equals the sine of theta plus phi divided by the cosine of theta plus phi, because this was our identity. So the sine of theta plus phi is sine of theta cos of phi plus sine of phi cos of theta. And the cosine was cos of theta cos of phi minus sine of theta sine of phi. Well, first thing that we want to do is that we notice that if we divide both of these terms, or we factor out, the cos theta cos phi will divide over here by cos theta cos phi. This would leave us with tangent terms because the sine theta and the cos theta match up, and the sine phi and the cos phi match up. So let's go ahead and do this. Keep our sine the same for now, plus sine phi cos theta, all divided by cos theta cos phi, factored out, so we left a 1 here, minus, and as we discussed before, the sine phi and the cosine theta. I screwed that up. The sine theta and the cosine theta make a tan theta, and the sine phi and the cos phi make a tan phi. Now all we have to do is just divide this term to each of them. So let's just look at them separately. Let's look at this one in blue and look at this one in green. So sine theta cos phi over cos theta cos phi. Notice that this cancels out to 1, and this leaves us with sine theta over cos theta. Well, that's tan theta. And now, the other expression in green we're going to handle, sine phi cos theta over cos theta cos phi. These two terms are going to cancel out, and sine phi over cos phi, that equals tan phi. So now, when we take this term right here and we divide the top, we're going to be left with tan theta plus, because we have our plus here, plus tan phi, giving us our compound angle formula for tan of theta plus phi equals tan of theta plus tan of phi, all divided through by 1 minus tan theta tan phi. So now, whenever you approach a trig formula where we're adding something to an angle, so it's a sum of angles, we can use our compound angles to figure it out. In fact, if I ever do an algebra series, you could actually do so much more. You can find so many angles using this formula right here. I think that's a wrap for now. And as always, keep on learning.